evolving virtual creatures using neural networks and genetic algorithms. Every creature has been given a neural network to simulate the workings of a biological brain. The neural network consists out of 3 layers of neurons, each connected by dendrites. The input layer is where we will input the data from the creature's sensors, in his case, the distance from both left and right antenna to the closest food source. When the neural network computes its outputs, calculations are made based on the value of the neurons and the dendrite weights that carry them to the next layer. We use the outputs to alter a creature's rotation. In this case, the first output wants to turn right, the second left. The one that generates the highest number wins. Let's see it in action. Here is a population of 100 creatures, each with their own neural network. The creatures need to find the food sources, marked as green circles, to survive. If a creature fails to do this, it will die. The creature's neural networks are all generated at random, reducing the chance to produce duplicates. Some creatures may seem to act alike, but they just found a different way to the same goal. The creatures can use their brain to detect input and produce an output which alters the creature's position and rotation in the world. This alone, however, is not a learning process. To add an element of learning to the simulation, we will use a genetic algorithm. What is a genetic algorithm? It's a search method that mimics the process of natural selection. Or in other words, survival of the fittest. We start out with the initial population of our creatures. Next, we select the fittest among them based on how well they did in the simulation. Those fittest creatures mate with each other to create offspring. At the very end, we have a very small chance that some mutations will occur. When all this is done, we end up with our new population. Let's have a closer look at this genetic algorithm. In this genetic algorithm, we keep 40% of the best creatures and eliminate the rest of them. In the crossover method, we select parents out of the creatures that were kept. With the only rule being, a better fitness has more chance to get selected as parent. When 2 parents are selected, their chromosome consists of all of its neural network weights. A random crossover point is chosen and both childs will have parts of both parents' chromosome as result. Mutation should not happen a lot. If the chance is too high, the genetic algorithm would just be a brute force search. When mutation happens, 1 or more random selected genes are altered as a result. With the genetic algorithm, they will learn to become better each generation. Let's watch them for a while. Are you still there? Let's add some obstacles and see how they do.